Hello everyone. So today's problem is based on elasticity. So the problem statement is that we have a uniform rod that is free to rotate in a vertical plane about a horizontal axis passing through one of its ends. The rod is released from horizontal position shown in the figure, as shown in the figure. Cross-sectional area of the rod is A. For calculation of moment of inertia, you can treat it to be very thin. The shear stress developed in the center of the rod immediately after it is released. So give this problem a good try, guys, and then check out the solution. Okay guys, so now let's begin with the solution. The weight of the rod will act at the center. So the angular acceleration of the rod is simply the net torque about the point O divided by the moment of inertia about the point O. And the angular acceleration, after substituting the values, we get it as 3g by 2L. So now in the question, they wanted us to find the shear stress developing at the center. Now guys, whenever they ask shear stress, the first thing you have to do is section the rod at that particular point at which the shear stress is asked. Okay, so in this case it's a center. Now the question is, should I take the part on the right of the center or towards the left of the center? And the answer to that is, for the sake of simplicity, the part on the right is better, because if you're taking the part on the left, then you have to account for the hinge forces as well, which you have to determine in that case. So we are going to take the FBD on the right. Now let's mark down the forces on this. So first we have the weight of this part, as this is simply half the rod. The weight of this part is going to be mg by 2. We can easily determine the acceleration of this part, right? So let's say this was the hinge. Distance of the center of this part from the hinge is 3L by 4. So the acceleration of the center of mass of this part, which if you solve comes out to be 9g by 8. The vertical acceleration is actually greater than g, which means there must be some force in the downward direction that is kind of pushing this element downwards. And that in this case is going to be the internal shear forces. So let's give it a name of V. Now guys, there will be some internal moment as well. But the thing is, we don't really care about this for this question, because we can easily figure out V by writing F equal to ma in the y direction. So we don't really need to take care of the moment equation. Okay, so now what we are going to do is F equals to ma in the y direction. So the net vertical force is mg by 2 plus v. This would be equal to the mass of the part times the acceleration, which is 9g by 8. And after solving, you'll get the shear force as mg by 16. So from Newton's laws, we figured out that the internal shear forces at the center is mg divided by 16. So if you want a cross-sectional view of how this looks, it'll look something like this. Okay, so the shearing forces are the forces that act parallel to the area of cross-section. So the shear stress, which we denote as tau, is nothing but the shear force divided by the area on which it is acting. So this would simply come out to be mg divided by 16a, and this would be our required answer. So yeah, that was it for this video, guys. If you have any doubts, you can comment down below. Do like, share and subscribe if you enjoyed the video, and that's it. Thanks for watching.